Rightio then. So this is going to be our first lesson for Algebra 1, and I'm on the wrong slide to start out. So this first lesson, we're going to talk about one variable equations and basically just brush up on super basic algebra skills here. So our essential questions are going to be here. We've only got three. What's the difference between expressions and equations? How can we create an equation in one variable from a real world situation? And how do we solve an equation in one variable, right? So let's start off by answering EQ1 right off the bat. What's the difference between expressions and equations? So an expression would be something like x plus 3, right? And it doesn't have to have an x. It can be an actual number. We can say x plus 3. We can say, 4 plus 3. It does not matter. But for now, I'm going to leave it as x plus 3. This would be an expression, right? And I thought it would have switched back to, there we go. This would be an expression, okay? And an equation would be x plus 3 equals 2. Okay, so what is the difference here? Well, equations have equal signs. Okay, expressions do not have an equal sign. Okay, so that's the difference between the two, to put it, really basically. All right, so on to EQ2. How can we create an equation in one variable from a real world situation? And I have, however remarkably stupid of a situation, but I have an example of a situation that we can use to make a one variable equation from, right? So here's the situation. Tamale Tommy can eat 5 tamales per minute. So we're asked to do several things. The first thing we're asked to do is write an algebraic expression, right? An expression meaning there's no equal sign. So write an algebraic expression that represents the info above, assuming that m represents the number of minutes, right? So very simply, to explain this, 5 tamales per minute, well, we would just say 5 times m, right? 5 times m, 5 times the number of minutes, that's 5 tamales per minute that he eats. Okay, so that's our expression that represents the situation. Now we're being asked to write an equation that represents the number of tamales that Tommy eats in m minutes, right? And tamales is represented by the letter T, so the number of tamales is equal to, well, this expression here. 5 times the number of minutes, or T equals 5 times M. Okay, so pretty simple. So that pretty much covers our EQ2, how we can create an equation in one variable from a real world situation. All we're doing is gathering the context from the situation, right? And we just established the pattern mathematically that we see in the situation, in the context. Okay, so we've got one last thing to do. Okay, so now we're being asked to write an equation again, except this time the number of tamales that Tommy eats in H number of hours, right? So this is something that you're going to see and be expected to know how to do in the upper science classes, and you should start learning this in chemistry, I believe, and most of you are going to be in chemistry if you're in Algebra 2, you're juniors or sophomores. So that said, okay, how would we convert from minutes to hours? Well, common sense tells you just multiply by 60, but it's not always that simple, right? So let's write out the rate that we've got. So the rate of change, the rate, or like our slope, is 5 tamales, I'm just going to abbreviate, per every 1 minute. This is our rate. Okay, 5 tamales per 1 minute. And we want to change the minutes, right? We want to change the minutes into hours. Well, how many minutes are in an hour? 60 minutes are in 1 hour. Okay? And this works just like multiplying fractions, right? So if I have 1/2 times 3/4, right? You just multiply straight across. 1 times 3 is 3, 2 times 4 is 8, right? So it's the same idea here. We're just multiplying fractions. We're taking one rate, multiplying it by the other. So I've got 5 tamales times 60 minutes, 1 minute times 1 hour, right? And what's going to end up happening, so if I write this as one giant fraction, 5 tamales times 60 minutes over 1 minute times 1 hour, right? If you think of things that are going to cancel out, okay, minutes divided by minutes, well, that's like 1. That's like a canceling of units, right? So what we're really left with, if I can just back up here, what we're really left with is simply 5 times 60. Well, duh, that's just 300. So we would say we have 300 tamales, right? So the minutes canceled, and we're left with hours. So 300 tamales for every 1 hour, or 300 tamales per hour, right? So 300 times the number of hours is now equal to t. So we have the same equation except in different units. One is in minutes here, and this guy here is in hours. Okay, both really doing the same thing, right? But one is in one kind of units, the other is in the other. Okay, so now we're being asked to use what we've got. Okay, so our equation in minutes is t equals 5m, or t equals 300 times r, right? So he eats 300 tamales every hour. Okay, so write an equation that represents the number of minutes it took Tommy to eat 600 tamales. So let me change colors here instead. Let me go to yellow. Okay, so now we're kind of flipping the script here. We know how many tamales there are, right? But what we don't know is the number of minutes. So if we just put everything where it goes, so 600 is our tamales, and that's equal to 5 times the number of minutes. And all this is simple basic algebra, just solving for our missing letter here, right? So the inverse of times 5, of course, is divided by 5. And we get that m equals 300. Or to answer our question, right, and that is completely wrong. It is not 300. Sorry, kiddos, I haven't slept much. It would be 120. Okay, so the number of minutes that it takes for Tommy to eat that many tamales is 120 minutes. Okay, so that would be our answer here, right, for number 2. Kind of did a twofer there. But what the equation would have been is simply just the 600 is equal to 5 times m. That's still just t equals 5m. Okay, so what does our solution mean? Well, it takes homeboy 120 minutes to eat 600 tamales. And I have no idea how he would still be alive after that. That's I don't know. He'd have to defy physics. Okay, so write an equation that represents the number of hours it takes him to eat the 600. Okay, so same idea. 600 equals 300 times h. Okay, we're using this equation now because we're talking about hours. Same idea, we're going to divide by 300 and we get that h equals 2. Okay, so what does it mean? Kind of answer number 4 and 5 at the same time. What does our solution mean? Well, it takes him 2 hours to eat, 600 tamales. And of course, 120 minutes, 2 hours, same thing. Okay, so moving on, we've got some basic equations here. Okay, so EQ3, how do we solve an equation in one variable? How do you solve any equation in however many variables? You're going to use inverse operations, right? And that's not a new concept. It's something we did extensively in geometry. So let's go ahead and solve this first one. So 6 plus 2x equals 24, and these are all actually equations from the do now, right? So if I'm going to solve this, 6 plus 2x equals 24. Okay, we're just going to undo everything that's here to get the x by itself. So we're going to work from the outside in, so the furthest out away from the variable that we're looking at is not the times 2, it's the plus 6. So we're going to do the inverse of plus 6, which of course is minus 6. That's going to give me 2x equals 18. Then we're just going to divide by 2 because that's the inverse of times 2. And x is therefore 9, right? And of course, we can check our work if we want to. I know this equation was super simple, but just to prove a point, right? We now know that x is supposedly 9, and if that's the case, that means that 6 plus 2 times 9 should be equal to 24. Well, let's see if that is the case. 6 plus 2 times x, which is 9, equals 24. This becomes 6 plus 18, and we, of course, can easily deduce that that is, yes, 24. Right? Next one, number 2. 1/3 all times y is equal to 15, right? And this is something I would have discussed with you when we went over the do now. So 1/3 times y. So we treat y like it's a whole number. We can say 1/3 times y over 1. And that, of course, is the same thing as y over 3. So if you want to write it that way, that's fine. I'm going to leave it the way it is just to show something. Or actually, I'll do it both ways because why not? Okay, so we're going to do the inverse of multiplying by 1/3, right? And you could say it's dividing by 1/3, right? But a simpler way to look at it is to say that we're going to multiply by the reciprocal of 1/3. That's the same thing as dividing by 1/3. So our reciprocal here, and let me put my arrow back, our reciprocal of 1/3 would be 3/1, or simply 3. And what I do to one side, of course, I do to the other. So 3/1, 1/3, their inverses, they'll equal just 3/3, which is 1, times y, which is just y. 15 times 3 is 45. And again, if we check our work, so if I do 45 times 1/3, I should get 15, right? And when I actually multiply this out, that would be 1/3 times 45 over 1, so 45 over 3, which of course is 15, right? Another way we could have done this is if I wrote the problem down differently. If I instead represented the 1/3, or multiplying by the 1/3 instead of like that, whoops. If I instead wrote it as y over 3, like I showed you a second ago, the inverse of dividing by 3 is multiplying by 3, we get the exact same thing. Y equals 45. Okay. 2 more. 10z minus 7 equals 43. Add 7 to both sides. Divide by 10 on both sides, and z is simply 5. And if we multiply it back out, or if I plug in for what z is, so instead if I have 10 times z minus 7 equals 43, right? We know this is going to work. 10 times 5 is 50, minus 7, 43. Just like we should get. Okay, last one here. Okay, so for this one, we've got an x here and an x here. So when you see equations like this, you want to have all the variables on one side and all the constants on the other. So in other words, I want all the x's on one side and all the just plain numbers on the other, right? But before we can do that, we need to go ahead and distribute this 3 and then see if we can't combine some like terms. So 3 times x, 3x, 3 times 2 is 6, plus 4 equals 5x plus 7, right? We can combine the 6 plus 4. So that leaves me with 3x plus 10 now. Okay, so what I'm going to do now, I'm going to move, right? I'm not actually moving, but it's kind of like what I'm doing. I'm going to move all the x's on one side and all the constants on another. So I'm going to put this 3x over here on this side by simply doing the inverse of positive 3x, which is minus 3x, right? So I get 10 equals 5x plus 7 minus 3x. And then I want this plus 7. I want this over here with its constant buddy over here, the 10. And of course, to do that, I'm just going to do minus 7. So I've got 10 minus 7 equals, and I can go ahead and combine like terms. 5x minus 3x, well, of course, that's just positive 2x. And then the 10 minus 7 is, of course, simply 3. Divide by 2 on both sides. And we get that x equals 3 over 2, which you can represent as a mixed number, 1 and 1/2, or you could also represent it as a decimal, 1.5, right? So, a few more examples just to make sure we've got it, and I'm going to go through these pretty quickly because I'm already at 15 minutes for this video, and I'm trying to keep these videos really short. So, all I'm going to do here, I'm trying to get the a's all on one side, so I'm going to subtract the 6a, so this becomes 4a here on the left, and then I'm going to add, so I did minus 6a, and then plus 8, right? So that way all the letters are on one side, all the constants or plain numbers are on the other. So the plus 8 and the negative 9, they combine to give me negative 1. Divide by 4 on both sides, a is simply negative 1 over 4, right? Which, of course, if we're thinking decimals, that would be negative 0.25. Okay, over here. So here we've got a little bit of a problem, and this is a little different, right? We don't want this ugly fraction like this, and we can do a very simple thing to make it go away. Well, what if I just, and I don't know why there's a C here. That's just going to bother me. There we go. So what if I just multiplied by 3 on both sides, right? The inverse of dividing by 3, is multiplying by 3. And what I do to one side, I do the other. So I'm going to have to distribute a 3 in here. This is simply going to become 3c plus 6 equals 2c plus 10. And now I don't have a stupid ugly fraction anymore. I'm going to do a lot like what I did here earlier. Put all the c's on one side, put the 6 and the 10 on the other side. Okay, so minus 2c, this leaves me with just c on the left. Okay, and minus 6, that leaves me with just 4 on the right. C obviously is 4. Last example, 4 minus 2d equals blah, 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 blah. Okay, so we're going to have to do a little bit of, we call it order of operations here. So we've got grouping, and we've got an exponent. And then we've got division, and we've got a whole bunch of stuff. But what this really is a big old, single term of grouping, right? So that means grouping always comes first, or parentheses. Grouping always comes first in the order of operations. So I'm going to go ahead and take care of this. Okay, so 13 minus 8 all squared over 5. I'm going to do the grouping up here first, and then the exponent, and then divide by 5. All right, so 13 minus 8 is 5. 5 squared is 25. 25 over 5 is simply 5. So all of this simplifies down into just 5. Okay, and then same like I did over here, right? I want to get everything all, mixed and matched. Okay, so I'm going to do plus 3d, and I'm going to do minus 5. Oops, no, I'm not. I'm going to do minus 4 and minus 4. Okay, so what that's going to end up being is going to be d is equal to 5 minus 4, which is 1. So that concludes this video. I only just barely kept it under 20 minutes. I was hoping to do like 10 or 15, but what are you going to do? Well, that's all for this lesson. Have a great day. Shoot me an email if you need anything. You guys know you can reach me whenever. Other than that, goodbye.